And welcome back. So I wanted to kind of shoot this and put this at the beginning of the video you're about to see. And what you're going to see in this video is that we're just covering a little bit of doing this wiring repair to this section of harness here. As you can see, it looks like they had, the previous owner had a lot of third-party aftermarket stuff tapped into this harness for one reason or another, or it could very well be that somebody attempted a repair on the steering column in the past and maybe just spliced in what they wanted to replace. Well, you know, who knows. Rather than show this step by step, which would be cutting the wire, removing the tape, cutting the wire, stripping it, tinning it, soldering it, and then heat shrinking it, I'll kind of show you this as I go, because trying to put out any type of a soldering video, like you'll hear me make a comment in the contents of the next video, but putting out a soldering video, especially if you try to call it a tutorial or anything of that nature, tends to generate a lot of how should I say, passionate comments on it. So that's primarily the reason why. I'll show you my method of it, and again, this is not a how-to, but I just wanted to kind of explain as to why I wasn't showing this next sequence exactly step by step. So with that being said, I'll start the video, I'll splice you into the video at this point, and then we'll continue on, and I'll catch you in a bit. Bye. And welcome back. So I figured for this video, remember in the previous video, if you recall, we stripped out all of our dash items here and kind of left it as you see here. We did get that one actuator replaced for the recirculation door that you can see. I believe what we'll do in this video, we'll go ahead, because the other two actuators did come in, so we'll go ahead and get those other three actuators replaced. But in this one, primarily, we're going to focus on this rat's nest butchered up wiring that you see here. And again, pardon what sounds like aggravation on this, but I mean, T-taps like this, in my opinion, are okay. They're significantly better than what was done here. But as you can see, you know, wiring, again, wiring, neatness of wiring, just it's a pet peeve of mine. So what we're going to do is that we're going to take off the little round things, electrical tape here, clean these wires up, get them tinned, get them soldered, and get them heat shrink. So you can see we kind of got our tools of destruction down here. Just a little variable temperature soldering station, just a generic one off Amazon that uses a handle that uses the very popular T-bits, as they're called. Just some nice lead solder. This is not a, I believe that is silver. Nope, that is silver and lead. Okay, so that is the old-fashioned leaded solder. I prefer it when it comes to doing electronics work. That is just me. I think it flows a lot better. Don't get me wrong. Silver's got its place, and I've used silver before, but when it comes to electronics and wiring, I prefer the good old-fashioned lead mix. Just be careful when you're working with it. Wash your hands afterwards. You know, don't eat it, things of that nature. And of course, you can see we got our heat shrink here. We've got a heat gun to heat shrink our heat shrink. And originally, I was thinking about just putting butt splices in here, and the type of butt splices that also shrink around it and squeeze out the sealant. But I've elected not to do that after thinking about it a bit, since this is going to be under the dash and susceptible to vibration and moving. As you can kind of see me move the wiring harness around here, it'll be a lot more stable once we have the steering column remounted. But you know, again, truck traveling down the road, hitting potholes, things of that nature, bumps in the road, I don't want to put a butt splice in here, even though I know they're secure, especially the ones with the sealant on it. I don't want something breaking loose, so I'm going to solder these just for the longevity of things. So you can see we got several repairs here to make. We've got this one, which we found earlier when we were taking the dash apart. It's got a cut in the wiring there, another cut in the wiring there, a cut in the wiring there. So I may have to splice in some extra wiring to get around that, because it doesn't, well, you may actually have some slack. If I cut this tape here, we may have enough slack in here to join these back together. If not, I've just got some old appropriate gauged alligator clip wiring. I'll just splice in some wiring on this. Now, this is a bit unique, and this is kind of what we need to be careful of. This is the airbag circuit, because you'll see that these two pairs are twisted together, and per the manual, the coloring, the twists, those line up to be exactly that. The reason why they are twisted is to minimize crosstalk. You don't want an excessive amount of stray current to end or stray voltage to end up on those wires and then induce a current and inadvertently set an airbag off, especially the one right in your face. So we just need to be careful that, you know, we're going to take some of the twist out of here to repair this, but we need to be mindful of trying to put those twists back in after the repair. I'll see what I can do about that, because you can see that some of these breaks, like that one right there, which is broke into the insulation, is actually on a twist. Like I said, just something to be mindful of, because you'll notice none of these other pairs are twisted. It's not just airbag circuits that do that. It's usually any type of communication circuit in which you want to minimize crosstalk, like a lot of communications cabling that goes to your PC. You know, Ethernet cable would be another example of that. You have several pairs of twisted wire that are inside that jacket. I'm rambling. So what I'm going to do is, oh, and I forgot to show you this one. This is what I use for flux. Yes, I got this big old bottle of flux many years ago. It's probably enough for, you know, several lifetimes. The soldering, depending on how much that you do, just good old rousing core flux. What I'm going to do is, again, get everything stripped down, get the both sides of the brake fluxed up, tinned, and then we'll solder the wire back together and slide a piece of heat shrink over it, get it sealed in place, and then kind of push it off to the side and move on to the next one. And you can see that we've got quite a few, unfortunately, in this harness that were tapped into for whatever reason, whatever multitude of aftermarket devices that were plugged into this wiring harness. I'm going to try my best to stagger these so when you bundle them together it looks better, but just based on where the brakes are at, that might be a little hard to do. So it may just kind of look like a, you know, a lump in one area when it's done. And with that being said, I'm going to go ahead and work on the first repair here, and I'll bring you back when it's done and kind of show you what I'm talking about. I'm not really going to video the individual steps of how I'm soldering this. I'll kind of show you once it's done what I've done. I'll shoot a bit of a video and splice it in the beginning to this and kind of explain why. I'll show you as much detail as I can, but suffices to say that making soldering videos is kind of like having a conversation on religion or politics, or, you know, insulting someone's family member, as well as, you know, torque requirement videos as well. Tends to generate a lot of anger for one reason or another. But I'm gonna let the video go at this point, and then I'll bring you back when we get close to our first repair here. Thank you much. Bye. Okay, and welcome back. So again, step one, just removing the tape. You can see there was no other method of mechanical connection on this wire other than it was just twisted together. So what we're going to do is, you can see we've got plenty of slack in there to overlap this wire quite a bit. So we're just going to cut off these ends, make them clean, get them stripped, tinned, and then ready to be physically joined together in the bonds of, I guess, wiring bliss, if you want to call it that. But with that being said, again, that was kind of step one. And again, I'm only going to take these one at a time, just to make sure that we don't inadvertently mix up and connect something together that shouldn't be. Although everything is color coded, there are some wiring in here that is very similarly color coded. So again, one wire at a time, just make sure that we're putting stuff back together that was at least together, or at least twisted together by hand when we did the repair, and I can see the color coding and the stripe on this one does in fact match its counterpart, so we're good there. So let me get back to work more on this, and I'll bring it back once we have these cut, stripped, tinned, and ready. And again, just to show you what I'm going to use for the tinning, you saw the flux earlier down there on the ground, so I'll take a standard Q-tip, dip it in the flux, and put a little bit of flux on this wiring. Once we have them stripped out to some nice clean copper, we'll hit it with the iron, go over it with a little bit of solder individually first to get these nice and tinned, and then we'll put a piece of heat shrink on there. Remember, put your heat shrink on before you make your connection, otherwise you'll be desoldering that. And then we'll get them joined together and we'll get them heat shrinked up. But that being said, I'll bring it back in a bit. Bye. And welcome back. You can see we got our wire cut. You can see we got it stripped at this point. That's usually about how much I like to strip off, provided I've got the wire length appropriate to play with. Now, when I'm done and I have these stripped, I usually like to take the inner strands and just kind of twist them together, make them as much as one as I can. And then I take just a little Q-tip in this case and just wipe them down with a little bit of flux. It doesn't take much. And what flux is basically, and I'm going to give you my explanation, and it may not be 100% perfect, but basically flux is it's a material. It's kind of like an acid. It's going to react to the heat of that soldering iron, and it's going to go through and clean up this copper and basically get rid of the oxidation, the other impurities that may be on that, and allow that solder to stick a lot better than it would be if you did it without. Now, different types of solder on the market. This is rosin core solder, so it does have that flux, kind of like the same flux that we use in a liquid form, on there already. So just by applying solder to it, it will activate the flux core in this and kind of clean from there. But I like putting actual just extra flux on the wire to make sure that we get a nice good clean bond, because this is I'm using some fairly thin gauged solder. So that core is in there, believe it or not, it's still there, although, you know, pretty small. So you're getting a very small amount. But, you know, for electronic soldering on circuit boards, usually those joints are pretty small. It's usually like kind of like the diameter I like to use. And that is, if you see it there, 0.032, looks like a 22 gauge. On this particular roll, you can get, obviously, like I said, various different sizes up to some, you know, monstrosity type stuff if you're, you know, soldering quite big cables that may carry a lot of current. But that being said, I'm going to get these tinned and I'll bring you back. And again, all tinning is, I'm going to bring the iron up, I'm going to hit it to the wire, I'm going to feed in a little bit of solder, and that's going to wick in to those individual copper strands and basically get everything coated. Now, everything I said thus far, this is where it starts to generate a lot of hate if it hasn't already. Everybody has a different method that they like to use when they invoke soldering. Some will take these two strands, and it's perfectly fine, twist them together ahead of time, make like a joint, put them together like that, twist them together, get them the hook and get a mechanical connection on it, and then solder it. And that's fine, that's great. You can absolutely do that. I am just using this method because I've used this method for decades and it's been fine. I've never had a joint pull apart. I've never had wires separate. Again, when we get done, we'll have a nice strong mechanical connection on here. But just to let everybody know, I'm not saying this is the way that you need to do it. And I'm also validating and aware that there are several other ways of making a solder joint. And depending on the career field that you are in, can also dictate exactly how you need to solder something based on the type of equipment it is. If it's your, you know, working on something that's medical grade, you have standards, and those standards will dictate exactly how you are to perform certain repairs. So I guess what I'm saying is I'm going to use this method on this particular wiring bundle, you use the method that you were happy with, and hopefully, you know, we can all get along, and I won't get a ton of hate comments for this. But we shall see. I'm going to get these tinned up, and I'll bring you back. One moment. Okay, welcome back. You can see that there. You can see that we're coated with solder at this point. You can also see, I don't know if the camera will pick it up, but you can also see that you can still see some of the individual strands of copper in that wire, and that's what I'm looking for when I'm doing my tinning. I don't want to put so much solder on there that it looks like, you know, one glob of solder when you're done, and that's where that additional flux comes in handy in helping you do that. And again, why I'm using such a small diameter core solder, because these are some pretty small wires. It doesn't really require for anything heavy duty. But there you go. Now that we've got them tinned, I'm going to get a piece of heat shrink cut, which I already have here. I'll get it slid onto this wire since I have the most real estate behind the solder joint to play with. And then we'll get those two wires together. And what I like to do, and again, this is just me, is that I will put a little bit of solder on the end of under the tip, get it ready, hold these two wires together like this, and then touch the soldering iron to them, get that solder to flow on both halves, and then hold it in place until it sets, and then I can slide my heat shrink on it. Now, if you see that there, you see how that kind of overlaps, where this lead is a little bit longer than that one. What I usually like to do is trim them up so they're nice and even with each other. So when I lay them up, basically end for end, solder end from solder end will meet up. And you can see this one's just a little bit longer, so I got to trim a little bit off the tip of this one, and then we'll be good. So I'm going to take care of that, and I'll bring you back. If you're curious, I'm just using a small conical tip on this iron, and I'm running about 325 degrees Celsius camera. It's going to flicker in the camera, I'm sorry. It's an LED display on this iron. So again, depending on what I'm doing, what I'm soldering, that's why this station is nice, because you can vary the degree. And right now it says we're running about 325 degrees C for this particular connection. If you in case you're wondering, sorry, don't mean to ramble, the reason why you would want a solder station that you can vary the temperature on is depending on what you're soldering, especially if you're soldering electronic components. A lot of those components have a heat tolerance, and you don't want to exceed it, otherwise you'll damage the component that you're trying to install. Again, just a useless trivia for you. So with that being said, let me get these let me get this wire trimmed up. We'll get a piece of heat shrink on here, get these joined up, and I'll bring you back. Thank you much. And welcome back. You can see that we've got our two wires joined together at this point, and you can see that is a nice strong mechanical connection. That is not going anywhere. That'll do the job just fine. So again, as you saw, I did trim this one up. I just lay them both side by side, put a little bit of dab of solder in the soldering iron, and then kind of touch everything together and make sure that the solder that I put on this one as well as that one heat up enough where they melt together, and there you go. What you end up with is a very nice strong connection. And now that we have our heat shrink, we can take our heat shrink piece, slide it over our wire. We'll get a little hot air on that. We'll get that heat shrinked up, and then that will be good. We'll move on to the next set. But let me get that heat shrinked up, and I'll bring you back and kind of show you the final piece. And welcome back. So you can see we got our heat shrink in place, all shrunk down. You can see you can kind of see the joint right there in the center of the heat shrink. And what I'm doing to protect the wiring, because I am using a heat gun to show you that, is I'm just using one of the brackets that came out when we removed the dash, kind of put it in the wire like this, and then putting the heat on it. Just to kind of serve as a shield, so I don't overheat anything back there and potentially melt it, because I am using the heat gun to do so. And there, again, there's many ways of shrinking. Heat shrink, heat gun is one method. You know, I'm not going to say that I haven't done this, but I have several times in the past. You can use a cigarette lighter if you got one, match, so on and so forth. Heat gun's a little bit safer because you're not dealing with open flame. But again, just my opinion. So I'm going to do this same process for the remainder of these wires. And just again, the whole purpose of this is to clean up all of this, get everything mechanically secure again. And then when I get this bundle done, I'll bring you back. And again, that's our airbag circuit. We're gonna have to potentially play some games with that one. But with that being said, I'll get cracking on this and I'll bring you back. Thank you much. And welcome back. So hopefully you can see that sun's a little bit lower in the sky. And it took a good couple hours to go through here. It's just, like I said, it's just a little bit tedious with all the stripping, tinning, heat shrinking afterwards. But I count 14 wires in that bundle that had to be gone through and basically had the old manual twist together, undone and repaired, as you saw. Just wanted to show you this one. I did the best I could with this. This was the airbag wiring that had some cuts in the insulation, so I removed the sections of the insulation I had got cut into and just extended the wiring a little bit with some scrap wire. I did maintain the twist as much as I could. Hopefully you can see that. And also just put a small tie wrap in the very end of that just to kind of hold that twist. You can see those two tie wraps there. So that's, again, just trying to maintain that twist they had in there to minimize the crosstalk. Now, admittedly, not the most ideal set of fixes, but you know, I don't have 14 different types of wire with different color, with the matching colors and the matching color stripes. You just, anybody that's going to come in here and potentially maybe troubleshoot this in the future is just going to have to, obviously it's easy to tell that, you know, these have all been repaired, and some of these, you know, after I cut out the damaged sections, it was short enough, I just had to shore it up with a, you know, another piece of jump wire. But and again, there you go. It's all in there. It's all done. All the ones that we could find that were, like I said, manually cut into, or maybe accidentally cut into, who knows. Those have all been fixed. What I'm going to do now is just kind of bundle all this up together, make it look a bit neater, put one or two tie wraps on it, and then we'll follow it up with a couple of wraps of the fabric loom tape. Just to make it look a bit more presentable. Yeah, it'll be under the dash and you won't see it, but you know, we don't want this bundle spread out like this where, you know, you might catch it with your foot or something on that nature when you're trying to hit the brake or something, hit the brake or hit the parking brake, you know, who knows. But with that being said, it's, like I said, it's going to be a relatively short one. I just want to kind of bring you along, show you a little bit of that process. So to recap it, from the beginning of the video, what I like to do is just cut it, strip it back, put a little bit of our liquid flux on the wire itself, hit it with a soldering iron, tin both sides, bring both sides together, put a little bit of solder on the ironing tip, touch it to where those two wires are overlapping, let everything melt together. I'm sorry, put a piece of heat shrink tubing on it, solder those two wires together. Once it does, let it cool. Make sure you got a nice physical connection. Slide your heat shrink on and then heat it up with a hot air gun. Like I said, that's been my method. And yes, there are countless different ways to solder two pieces of wire together. Like I said, my method works for me, and I generally, I shouldn't say generally, but I've never had a problem with a, you know, wire coming apart. So with that being said, if you haven't subscribed, please consider doing so. We are at, I think, 972 subscribers, and I thank everybody that has subscribed thus far. Our goal is to get to that 1,000 member mark, which will allow us to start taking the channel in more directions and doing more builds and helping us out with the existing builds. So if you found the information useful, again, if you haven't done so already, please consider to do so. It does help out. And with that being said, I will cut the video at this point. It's going to be a little shorter than normal, and I will bring you back for the next one. Thank you much. Bye. Okay, real quick, sorry. Just wanted to show you this. Put a couple pieces of the fabric loom tape on it. You can see it looks a heck of a lot better than what it did. Is it perfect? No, not by any stretch of the imagination. It's not perfect, but like I said, we're leaving things a lot better than what we found them. And now it looks like a nice little wire bundle rather than a big bowl of spaghetti exploded underneath the dash. With that being said, I'll talk to you later. Thank you much. Bye.